The atmosphere. Earth's preciously thin blue envelope of air. This ever-changing, fluid layer interacts with the planet's oceans in dynamic and complex ways. Water and air, two vital ecosystems that energize our planet, directly and indirectly affecting all living things on Earth. The Department of Commerce's National Oceanic and Atmospheric Administration, or NOAA, the nation's premier science agency, a highly trained team of dedicated scientists and personnel, working together through the agency's 7 mainline offices to monitor and probe the mysteries of the natural world. From orbiting satellites in space, replete with complex arrays of instruments, to climate laboratories next to frozen Arctic seas, and atop the summit of a Hawaiian volcano, in crystal blue tropical waters, restoring damaged coral reefs, in estuarine reserves and national marine sanctuaries along our coasts, in ports and harbors, in submersibles, planes, ships, and in offices throughout the world. The people of NOAA are seeking to understand, monitor, and provide stewardship for natural wonders that have fascinated humankind since the earliest hunter looked outward past endless oceans, slept under a canopy of stars, or sought shelter from a vengeful sky. NOAA people are charged with a vital mission to describe and predict changes in the Earth's environment and conserve and wisely manage the nation's coastal and marine resources. NOAA's array of polar orbiting, or POES, and geostationary orbiting, or GOES, environmental satellites keep watch on the Earth, monitoring and disseminating information, serving to enhance the nation's economy and improve the quality of life.
Near the city of Fairbanks, Alaska, NOAA scientists, engineers, and support professionals control and manage an array of POES satellites.
We have of course, all the antennas and equipment to support our satellite operations, but we also are essentially a small city. We command the satellites, we downlink data, we bring the data in, record it, and also transmit it out to our headquarters in Suitland, Maryland, where it's processed and distributed to users worldwide. We have an outstanding group of people here. Most of the folks working here have been in the field 15 to 30 years.
We take care of all the dishes that work here on the site. The mission requires us to be out there. If things are broke, we get up. It doesn't matter what the weather is. It could be 40 or 50 below, or it could be 90 above. We get out and fix them.
And it's a big family, and a lot of us, feel that this is our mission here. It's not only to help other people, but to be, you have to love what you do, and we do.
We acquire the hardware, and then we launch the instruments. We have the operations bringing data down. We have our group doing the research to make it into a product. We have the product distribution office sending the product out to users, and then the data centers take all of that information and they put it in an archive so that it's there for posterity. And there's many ways that the user can access our data. Basically all the information that is being transmitted, even through commercial enterprise, is from government weather satellites, and I think people don't always appreciate that.
NOAA utilizes the very latest advances in science and technology, scanning our sometimes volatile skies and oceans, issuing forecasts, watches, and warnings, informing the public each and every day.
I remember having to look at still images of the satellite pictures, and we primarily had to focus on the polar orbiting satellites, the pose imagery, and now we can even look at the GOES imagery. The resolution is much better. I think that's been very key, the advances in the satellite meteorology.
The forecast office is normally open 24 hours a day, 7 days a week. We'll have meteorologists on shift around the clock, and we have several different programs ranging from the type of forecasts we produce. We call them public forecasts that go out to the TV stations and the radio stations, newspapers. In addition, aviation forecasts, which are for the airports around the area and the routes between those airports. Forecasting for the shipping industry and also for recreational boaters, fishermen, and those types of folks. We also have a large fire weather program, and when there are large fires on these lands, we'll actually send our forecasters right out to the fires. We call them incident meteorologists.
All the weather gathering devices that we have, satellite, radar, observation systems like ASOS and other observation systems, computer model data, those all work to give the meteorologist a picture of the atmosphere and a sense of how the atmosphere is going to be changing. And once we have that picture in our heads, once we understand how the atmosphere is now and how it's going to be changing, then we can start putting out a forecast.
But with all this, I mean, when we're flying a storm, we know it's hitting land. There's the scientific excitement and curiosity. Like I say, when you see it on satellite, see a storm on satellite, or when we fly in the eye of an intense storm, it's awesome beauty from sea to the sky. But the way to say it, it's the beauty in the beast. We're seeing the beauty, but this is a beast. At a certain point, these things start to look ugly to you. I mean, you know what it's going to do and how it can devastate people's lives.
First of all, what we do is we save lives. We reduce property loss. I don't think there's anything more noble than that.
NOAA research is heavily involved in the basic and applied research and development of technologies for the causes of weather and for predicting weather. The National Weather Service is heavily involved in the delivery of service, the delivery of forecasts and warnings. The National Weather Service uses the results of NOAA weather research to do a better job of providing the products that we give to the American public, forecasts, warnings, advisories.
With the new WSR 88D Doppler radars, now not only are we able to see the rainfall patterns that we previously used to get with the old conventional radar systems, but we're also able to look inside and see the wind structure with tropical cyclones as they're approaching land areas.
When a system has been down for too long period of time, we go in, restore the system, and also provide any type of services required to restore the system in operation. So we all had to go through climbing training and certification, rescue training, to climb 100-meter towers or above. I don't think I can do the job by myself. We couldn't even perform the job that we're known to do without the talent of the people that they have here. That's something else I enjoy about this job is the multitude of talent, very sharp technicians, engineers, software support, logistics, meteorologists. Everyone is at the top of their game.
NOAA is providing the information, research, and tools necessary to warn and inform people in the path of potentially dangerous tsunamis that threaten the west coast of the United States, Hawaii, and Alaska.
This laboratory has developed a wonderful system as part of the DART project, D-A-R-T, Deep Ocean Assessment and Reporting of Tsunamis.
And sitting behind me here we have a tsunami DART buoy. And this buoy is moored in up to waters up to 6,000 meters deep. And presently we have 6 buoys in our configuration that are out there to monitor for the presence or absence of a tsunami. Now let's say there happens to be a tsunami coming up. The buoy will detect and trip the system instantaneously. So it gives us a really high-speed, accurate warning back to managers at both the Pacific Tsunami Warning Center and the Alaska Tsunami Warning Center to help managers make a better decision.
NOAA scientists are examining the forces that determine long and short-term climate change and variability, gathering global data on the oceans, earth, air, space, the sun, and the impact of human populations on the global environment.
Ultimately, we want to be able to understand the climate. We want to be able to forecast and see into the future. But to do that, you have to understand the small processes, the mixing processes, the exchanges of heat. You have to understand how the ocean can act as a memory and how it can store that heat to be able to understand the longer time scales.
We operate what you might consider to be the largest instrument in the world, which is a network of buoys spanning the tropical Pacific Ocean, transmitting their data to shore within hours of collection for monitoring, understanding, and predicting El Nino and the Southern Oscillation.
With the 1997-98 El Nino, which was also very large, NOAA predicted in June, July of 1997 what the winter of 97-98 would be over North America, and those predictions were remarkably accurate. From the point of view of society, that's a very useful thing because a 6-month forecast allows farmers to take appropriate measures, it allows emergency management agencies to get ready, and a lot of preparation that is very useful to society.
On the summit of Mauna Loa, an active volcano on the Big Island of Hawaii, NOAA Science is examining the chemical makeup of the atmosphere and how it relates to global climate change.
Well, we've been up here since 1958, and at that time we started measuring carbon dioxide. We've measured solar radiation since 1958, and then over the years, as technology has improved, we've added more programs. We measure a lot of different gases. We measure aerosol particles, we measure ozone, we measure things that are in the atmospheric column above us, the total ozone, the aerosols in the stratosphere, ozone in the stratosphere. I could just go on and on.
In Barrow, Alaska, Dan Andres and his dog Delta run a 24-hour-a-day operation.
I tell people it's pretty sick when you live in a place and when it gets up to 0, you tell them how nice it is. In the summertime, we have to walk up the stairs to get in. Okay, go. There are 2 people that run this station. I'm the officer in charge, and we have an electronics technician who keeps everything running. I tell him I'll split the work with him 50-50. I'll break it and he can fix it. Delta is 100% purebred Malamute. It's kind of nice to have kind of another 4 legs around the station. The Barrow Observatory is, of course, in Barrow, Alaska, 71 degrees north. It's the northernmost point in the United States. One of the reasons we're here is because there are no huge local sources of industrial pollution. We get good, clean background sources of air. What we do here is we're measuring any constituents that may force climate change, such as carbon dioxide, carbon monoxide, methane, aerosols, all the different halo compounds. We look for solar radiation as well.
A fleet of specialized NOAA ships and aircraft serve as mobile platforms to carry out NOAA's environmental and scientific missions, including atmospheric, weather-related, hydrologic, and fishery research. Ongoing assignments may also include remote sensing projects and coast surveys that help to produce and maintain accurate, reliable, and up-to-date nautical charts.
But we do rely heavily on NOAA ship time. In fact, one of the greatest assets that NOAA brings to this program, in addition to the funding for the hardware and the personnel salaries, is the fleet of NOAA ships that we make use of in servicing the array.
We submit the proposal and hope that we get funded to do it. And if we get funded to do it, then we pack up all of our equipment in our labs, put all this stuff in boxes, ship it out to the ship, get out there, set it up, and make the measurements and bring back the good data.
We have to produce the most accurate product as possible because we have a lot of people depending on our accuracy, from regular recreation boats to the main shipping imports and exports. It's been real interesting. You get to do a lot of different things. And we've come from sextants and lead lines to what you see now, almost fully automated. So even with automation here, we still have a lot to do.
Port Systems' goal is to provide safe navigation for the freighters and the commercial tankers and the oilers going up into the ports. It allows them to know the water density, the currents, the cross currents, the winds and the crosswinds, which are very important when you're bringing the big tankers in. And it also provides for the recreational boater also the same information for those who wish to know that, and it's all available on the website or through a dial-up system on each port. Each different port unit, then usually the pilots associations who are in that port, the marine exchanges who are the ones who track the pilotage in the port, or the port themselves decided this is something they wanted that would enhance their port to bring more commercial vessel traffic in. They would then contact NOAA. Port's representative will then get the equipment ready, which is a bottom-mounted platform and the equipment gear, the cabling to bring it back to shore. It's kind of an involved process to make all that happen.
NOAA has its own rigorous voluntary diver training program located in Seattle, Washington.
To study the oceans, man has to be in the oceans. There's only so much you can do from the surface. You need a person in the water interacting with the environment. NOAA divers do all kinds of things, from ship husbandry, such as doing hull surveys on our NOAA ships, cleaning sea strainers, removing debris from our propellers. We have divers that install tide gauges all over the world, even dives to the wreck of the USS Monitor in 235 feet of water. We have divers that are collecting data, all kinds of data, from chemical, geological, biological data, studying the reefs. So NOAA does a wide variety of tasks.
NOAA has the responsibility of establishing and maintaining the national marine sanctuaries. I see them as the beginning of the Yellowstone parks and the Yosemites beneath the sea.
The sanctuaries represent the first line of defense for marine conservation in America today. They're the places where we begin to preserve our marine heritage and our resources for future generations as well as for coastal communities. What's really most important is education. That we can do all the great research and science we care to do, but unless we can educate the American public, especially the American young, about the values and wonder, the excitement of these healthy marine systems and the heritage they provide, we're not going to be able to preserve them. They have come to see that working with the Marine Sanctuary Program provides them an opportunity to have a stake in their marine resource. That it's not the normal federal program. It's a program that reaches out. But most importantly, the value that they have depends upon them being healthy.
One of NOAA's most important responsibilities is the building and maintaining of sustainable fisheries and the recovery of protected species. It begins with solid science and research. The systematic gathering and sharing of information in order to obtain more accurate data helps to initiate informed management decisions.
The fisheries service is more than just about fish, it's about fishing, and it's people who fish. So understanding all the reasons and motivations involved and why people choose to fish in the way they do involves getting social scientists in, and that's why we have a social sciences branch.
We would expect the issues to be contentious because the decisions are important. And decisions that are important, people care about, and they dissect every aspect of the decision. So this is human nature, and it's just an indication of the important mission that NOAA is fulfilling here by conducting science on these marine ecosystems. We have a multifaceted program to assure that our science fulfills what I call the 4 R's. And those are, we want our science to be relevant, we want it to be responsive, we want it to be respected, and we want it to be right. The mission is a wonderful mission which, in spite of some of the rigors of dealing with these controversial issues, is one that everybody involved here in Woods Hole in the Northeast Center is excited about.
We do a lot of work working with industry groups here on trying to keep them apprised of regulation changes, which are occurring more and more frequently all the time. So a large part of my job, and an increasing part of my job, is education and outreach and trying to keep unintentional violations from occurring in people that want to do the right thing.
We have really 2 directives in marine mammals. One is the Marine Mammal Protection Act, the other is the Endangered Species Act. Stellar sea lions are declining, at least the western population, and they were listed as endangered. And the thing is, why are they declining? Well, they've declined 90% in the last 30 years. That's huge. And we're trying to figure out, are they starving? Are they being eaten by killer whales? Is it disease? Is it pollution?
The work I'm involved with is primarily documenting stellar sea lion abundance and distribution, their use of haul-outs around Kodiak. So I fly around in small planes and count them on a monthly basis. I work with the National Marine Mammal Lab folks who are doing captures and tagging of these animals and resighting of them. The biggest concern now is just that we get more data. I think the stellars will do okay. They're actually the ones I see are fairly healthy. I think they may be coming back in certain areas. The question now is, can we get data in hand fast enough to keep the regulations realistic and reasonable?
NOAA is listening to our oceans. Acoustic research is making it possible to monitor undersea volcanoes and hydrothermal vents, diverse fish populations, even different species of whales and marine life.
My job is basically design the ocean-going equipment, mostly related to the underwater acoustics. And this is one of the equipment I designed. And this is called the hydrophone, which is actually really a hydrophone for acoustic research in underwater. This instrument goes in the water below water surface between 500 to 1,000 meters. And right now, 7 of them are in Equatorial Pacific, and then 5 off Gulf of Alaska, and 6 in the Mid-Atlantic Ridge.
When we started listening to the ocean year-round, we found out that we had blue whales off of our coast here that we had no idea we really had in any great numbers. Same thing with our autonomous array that's in the Eastern Tropical Pacific. When we started listening, all of a sudden we got vocalizations, all sorts of low-frequency whale vocalizations, almost year-round. So by using acoustics, it actually extends the time that we can survey for whales. We can do it without having to be out there. I can sit here and drink coffee and actually do a survey for whales off our coast or in the Eastern Tropical Pacific. So it's really amazing. I'm very lucky.
NOAA scientists are pioneering investigations into the last of the unexplored frontiers on Earth, deep oceans.
The ocean floor has, more than 60% of the volcanoes on Earth. And we know now, after this past 10 years, we've been able to actually monitor these volcanoes out here and hear them as they erupt. And being able to do that and get out there very soon after the eruptions occurred, we've found that there's some very interesting things going on. One of them is that it produces large amounts of microbial activity. And this microbial activity includes organisms that live at very high temperatures. And so finding this, I think in the past few years, has opened up a whole new area of research for microbiology. The last dive we came on this wall in very deep water, about 1,000, 1,200 meters or over 3,000 feet, was just an amazing view of a whole new place. And that's really, really neat to be able to see something on the Earth, and someplace on the Earth that nobody has seen before.
The people we have met are representative of a professional team of personnel working within the agency. The NOAA workforce includes meteorologists, hydrologists, cartographers, oceanographers, fishery managers, physicists, computer scientists, engineers, technicians, law enforcement agents, and support personnel, to name a few. They come from diverse backgrounds and experiences, aware that they are part of an indispensable public trust, one of environmental assessment, prediction, and stewardship, knowing that the health of our economy is surely linked to the health of our environment. NOAA people are part of a strategy that integrates environmental, observation, assessment, and forecast services in order to enhance public safety and the nation's economic and environmental security, a purpose and mission that is reflected in the faces of members of the NOAA team who proudly look forward to and accept the many challenges ahead.
And we all work together for a common goal, which is to improve the service to the people of the United States.
For the most part, the problems that NOAA addresses have to do with saving lives and property, and so that's a very satisfying business to be in.
I'd say it's like playing scientific detective. Every day we come in with a new set of clues. We're trying to piece the puzzle together and answer the questions of what causes this and how can we use that information to forecast it. And the great thing about NOAA is that it affords us an opportunity to take our scientific knowledge, forecast some kind of phenomena that can benefit society.
I think I have the best job in the world. I'm happy to tell people that. I can't imagine doing anything else, or if I were able to design my own life, this is what I would do.